So welcome to the video. Today we're going to look at how to do a 2x3 between participants or between subjects or independent ANOVA on version 31 of SPSS. So we're going to use this test when we have two independent variables, one of which has two levels and the other of which has three levels, hence 2x3, and when we have a continuous dependent variable. So for this example, we're going to imagine that we have 24 males represented by these zeros here, and that we have 24 females represented by these ones here. And in this column we have music type. So we have a 0 representing no music, a 1 representing rock music, and a 2 representing classical music. And what we're doing is asking these participants how stressed they feel when listening to one of these two types of music or when listening to no music. So these scores here represent how stressed the participants feel listening to those types of music. So let's take a look at how to put these data into SPSS. So the first thing that I'm going to do is go down to variable view, and then I'll go to this name column and I'll give a name to one of the independent variables. So that's going to be gender, and then I'll give a name to the other independent variables. So that's going to be music underscore type. So I'm using an underscore here because I can't use a space. And then I'll give a name to the dependent variable. So let's call this stress. Next, I'll use this values column to specify what the levels of the independent variable are. So I'm going to click on this gender row, and then I'll click on this little box here, and then I'll click on this plus button, and I'll say that a 0 equals male, and that a 1 equals female. Then I'll go to OK, and then I'll do the same type of thing with this music type variable. So we'll go to this values column again, we'll click on this box, we'll say that a 0 equals no music, that a 1 equals rock music, and that a 2 equals classical music. Then we'll go to OK, and then we'll use the measures column to specify what type of variables we have. So gender is a nominal variable, music type is also a nominal variable, and stress is a scale variable. Next we can go to data view, and we can see that the names of these three variables appear at the top of these three columns. So now we're ready to copy and paste the data in. So I'm going to select the top left piece of data in this Excel spreadsheet. I'll scroll down to the bottom right piece of data, and I'll click on that while holding Shift to select all of the data. Then I'll press Command or Control C, and then I'll go back to SPSS, and I'll select the top left cell, and I'll go to Command or Control V to paste those data in. Sometimes that doesn't work, in which case you can just go to Edit and then down to Paste, and that will paste the data in. And we can see that the numbers that were in the spreadsheet have been replaced by these descriptions that we allocated to those numbers. So rather than a 0 and a 1 here, we see male and female, and that's because in this view menu we have value label selected. If I unselect that, we just get the numbers instead. So this analysis has a couple of assumptions. One of them is that the data are normally distributed in each combination of groups, and the other is that we have something called homogeneity or variance, which refers to the data being spread out to a similar extent in all of the groups. So we can check the normality assumption before running the analysis, and we can check the homogeneity or variance assumption as we run the analysis. So let's first check the normality assumption. So to do this, I'm going to go up to data and then down to split file. So I first just need to tick organize output by groups, and then I'm going to transfer my gender variable over to this box, and then I'll go to OK. And now whenever we perform a test, SPSS is going to divide the output according to gender. So there will be a male section and there will be a female section. So next I'll go up to Analyze, and then down to Descriptive Statistics, then across to Explore. Then I'll transfer my other independent variable to the factor list box, and my dependent variable to the dependent list box. I'll then go to Plots, and I'm going to untick stem and leaf, and I'll tick histogram, and I'll tick normality plots with tests. Then I'll go to Continue, and then to OK. So we can see here that this is the male section of the output, and if we scroll down slightly, we can find this test of normality table. And the thing that we're most interested in is this sig column, and what we want to see is the values in this column are above 0.05, as that suggests that the data within that combination of groups are normally distributed. So if we look here, we can see that we have a no music row, and in this sig column we have a value of 0.066. So as this is above 0.05, it indicates that the data for the no music condition among the males are normally distributed. And then we can see that we have the same thing here with the rock and classical conditions. We have values above 0.05, indicating that those data are also normally distributed. And then if we scroll down to the female part of the table, so we have to go past all these graphs, and then we can see that we have gender equals female, and then we have the equivalent test of normality table here. And again, we can see that for the females, all of these values are above 0.05, suggesting that the data are normally distributed in all of those conditions. So once we've checked that, we can go back to data and then back down to split file, and then we can tell SPSS to stop organizing output by groups and to instead analyze all cases and to not create groups. So we're going to select this and then we'll go to OK. And then to run the analysis, we can go up to Analyze and then down to General Linear Model, down across to Univariate. And then we can transfer both of our independent variables across to the fixed factors box and our dependent variable across to the dependent variable box. Next, if we go to Options, we can ask SPSS to provide us with descriptive statistics, estimates of effect size, and homogeneity tests. Then we'll go to Continue, and then if we would like to create a graph, we can go to Plots, and then we can transfer one of our independent variables over to this horizontal axis box. So I'm going to put gender in that box, and we can transfer the other independent variable to the separate lines box. So I'll put my music type variable down there. Then I'll go to Add, and the default is to have a line chart, but I prefer to have a bar chart. So I'm going to select bar charts, and I'm going to ask SPSS to provide us with error bars that represent 95% confidence intervals. So then I'll go to Continue, and then I'll go to OK to run the analysis. So this is the graph that SPSS produces for us. If we want to edit it, we can just double click on it to open the chart editor. And then if we double click on the bars, it opens this properties menu, and then we can choose, for example, a different color for the bars. So if I select one of these bars, I'll just click on this one here. That highlights that and the other one with the same color. And usually in APA style, we use colors on this grayscale for graphs. So those are any colors between black and white essentially. So I can replace this sort of turquoise color with this gray color here by clicking apply. And then I can do the same thing with these other bars so that they're all on the grayscale. You might also want to change the text. So if I click on any piece of text, I can use these menus here to choose a different font style and to choose a different font size. I can also edit anything in here just by clicking on it and then clicking on it again. For example, if I wanted to change anything here, I can just change whatever. Probably I wouldn't really want this thing at all. So I can just click on it and press delete, and that removes it. And you can do that with anything else you don't want to have in the graph. And when you're ready, you can just go to this red button and you can see that any changes you make in the chart editor appear in this output file. So that's how you edit the graph. Let's now take a look at how to interpret the results. So the first thing that we're going to look at is this Levene's test of equality of error variances. And we're going to look at this based on mean row. And the most interesting value is in the sig column, where we have a value of 0.704. And as this is above 0.05, it indicates that the homogeneity of variance assumption has been met. So let's now take a look at the results of the ANOVA itself. So if we go down to this test of between subjects effects table, let's look at this gender row here, and let's go over to the sig column, and we can see that we have a sig value of less than 0.001. As this is less than 0.05, it indicates that we have a significant effect of gender on how stressed people felt. Similarly, if we look at this music type row and at the sig column again, we again have a value of less than 0.001. As this is less than 0.05, there was a significant effect of music type on stress as well. Finally, let's look at this gender times music type row, and we'll go to the sig column again. In this case, we have a value of 0.184. As this is above 0.05, it indicates that we didn't have a significant interaction between the variables. So the definition of an interaction in this case is that the relationship between one independent variable and the dependent variable is influenced by variation in the other independent variable. So what you would expect to see for an analysis like this is that, for example, the females feel more stressed when listening to music A versus music B, whereas the males feel more stressed while listening to music B compared to music A. Here we can see that in both cases, the stress scores were lowest for the classical music, and they were quite similar among the females for the rock and no music conditions, and there was a bit of a difference for the males. So this difference between this bit of the graph and this bit of the graph might suggest there's something leaning towards an interaction, but generally what we see for the males and for the females is quite similar. So we haven't yet looked at whether males had higher stress scores than females, or whether certain types of music were associated with higher stress scores than other types of music, but we can do that whilst looking at this example here of how to report the results. So the first bit of this example says that a two-way independent ANOVA was conducted to investigate the impact of gender, male or female, and music type, no music, rock or classical, on stress scores. Next it says that Shapiro-Wilk tests indicated that the data were normally distributed in the case of males and no music, males and rock music, males and classical music, females and no music, females and rock music, and females and classical music. And each time we've referred to a combination of groups, we've reported some statistics. So here we have statistics relating to males and no music. So let's just take a look at where those come from. So we're going to go back up to the top of the output because we did the normality tests first. And here we can see that we're in the male section of the output. And if we scroll back down to this tests of normality table, and we can look at this no music row, and at the Shapiro-Wilk part of the table, we can see that we have the sig value of 0.066, and that is what we have here. We can also see that we have this W value of 0.83, and that's what we have in this statistic column, where we have a value of 0.834 in the no music row. So we've just rounded that value to 2 decimal places, and we have this degrees of freedom value of 8, which is what we have in this DF column here. And then we've just done the same thing for the rock row and for the classical row, and we've done the same thing for the female version of this table. So this is the female section of the output, and here's the female table, and we've just reported all of these statistics here. So next we've said that Levine's test for equality of variances suggested that the assumption of homogeneity of variance was met, and then we've reported these statistics. So let's just take a look at where those come from. So I'm going to scroll down towards the bottom of the output again until I find this Levine's test of equality of error variances table. And we can see that in the based on mean row we have the sig value of 0.704. And that's what we've reported here. We have these degrees of freedom of 5 and 42, and that's what we have here and here in the DF1 and DF2 columns. And we have this value of 0.595, which rounded to 2 decimal places is 0.60, and that's what we've reported here. So next we're getting on to reporting the results of the ANOVA itself, and we've said that there was a significant main effect of gender. So let's take a look at where those statistics come from. So we're looking at this test of between subjects effects table, and we're looking at this gender row here, where we have an F value of 14.27, and that's what we've reported here. We have the p-value of less than 0.001, and that's what we have here. And we have this partial eta squared value of 0.25, and that's what we've reported here. And we've reported these 2 degrees of freedom values, and those both come from this DF column, where we have a value of 1 in the gender row and a value of 42 in the error row. And we've said that the stress scores of males were higher than those of females, and we've referred to some means and standard deviations. So let's take a look at where those come from. So we're going to look at this descriptive statistics table. So if we look at the male section of the table and at the total row, which is where we have the mean stress scores for the males regardless of type of music, we have a mean value of 53.21. rounded to 2 decimal places, and that's what we have here. And we have a standard deviation of 7.88, and that's what we have here. And in the sentence we've just reported the same statistics for the females, so those are just coming from the female part of the table and from the total row. So next we've said that there was also a significant main effect of music type, and we've referred to some similar statistics. So we're going to be looking at this music type row in the tests of between subjects effects table, where we have a value in the F column of 43.46, and that's what we've reported here. We have a p-value of less than 0.001, and that's what we've got here. We have a partial eta squared value of 0.67, so that's our effect size statistic, and that's what we've reported here. And again, we have these degrees of freedom values of 2 and 42, so those are coming from this DF column and from the music type row where we have a 2, and from the error row where we have a 42. And then we said that stress scores were highest for rock music, followed by no music, followed by classical music, and we've reported some means and standard deviations again. So those are coming from this descriptive statistics table, and we're looking at this total section at the bottom, so we can see that the stress scores are highest for rock. So we have a 56.13 if we round that value to 2 decimal places, and that's what we've reported here. And we've reported a standard deviation of 5.67, and that's what we have in the rock row here. So we've just rounded this value here of 5.667 to 5.67. And then we've just reported the standard deviations for the no music condition and for the classical condition. So those values are just coming from here and from here. So lastly, we've said that there was not a significant interaction, and we've reported the same type of values again, but we'll just take a look at where those come from. So we have an F value of 1.76, and so now we're looking at the gender times music type row within this tests of between subjects effects table, and we have this F value here of 1.76. We have a sig value or a p value of 0.184. So there's the F value, there's the p value. Here's our partial eta squared effect size statistic of 0.08, and that's what we have here, just rounded to 2 decimal places. And if we look at the DF column, we have a value of 2 in the same row and a value of 42 in the error row, and that's what we've reported here and here. And then we've just reported means and standard deviations for each combination of groups. So we've said that among males, stress scores were highest for rock music, followed by no music, followed by classical music. And among females, stress scores were highest for no music, followed by rock music, followed by classical music. So let's look at the stress scores for males when they were listening to rock music. So we have a mean of 59.25. So we're going to be going to this descriptive statistics table again, and here are the males. And here's the row corresponding to rock music, where we have a mean of 59.25. We also have a standard deviation of 5.52, and that's what we've reported here. And then we've just done the same thing for the males and no music, the males and classical music, and then the females and no music, the females and rock music, and the females and classical music. So those means and standard deviations are just coming from this part of the table for the males and this part of the table for the females. So in this case, we didn't have a significant interaction. If you do find that you do have a significant interaction, you could consider doing some follow-up tests. For example, you could conduct some independent t-tests to see whether stress scores were higher for particular types of music when just looking at males or when just looking at females. And so to do that, you could go to this data menu and then down to the split file option. And you could again tell SPSS to provide you with outputs that are separated according to gender. And then you could run independent t-tests to see whether, for example, among the males, stress scores were significantly higher when listening to rock music compared to no music, compared to rock music, compared to classical music, and every combination like that. So if you're not sure how to run independent t-tests, I'll put a link somewhere to a video that I have about that type of analysis. But that's pretty much it for the 2x3 between participants ANOVA on version 31 of SPSS. I hope that was helpful. If you have any questions, let me know in the comments and I'll try to get back to you. Thank you for watching, and I'll see you next time.